Okay, so next one is the 12-minute mark. You can see it's going down nicely. 0.2, 0.4. Coming up on the 12-minute mark. And 34.7. Alrighty, we're coming up on the 13-minute mark. $34.6. I just stirred it a little bit in there. Okay, coming up on the 14-minute mark. I stir it from time to time with the thermocouple. 34.6, and change that time. Okay, we're coming up on the 15-minute mark. $34.3. Okay, we now are approaching the 16-minute mark. Let's see if it stays up there. Nope. 34.0. And we have 4 more measurements to go, so we're almost done. All right, 17-minute mark. Get ready. $33.9. All right, we're coming up on the 18-minute mark. Looks like it didn't change from before. 33.9. As it gets closer to room temperature, the rate will decrease, the rate of cooling decreases. Okay, so we've got 2 more measurements, and we are done with this specimen, the aluminum. Aluminum. This is steel. Okay, 19-minute mark is coming up. And it looks like it's sort of, I think it's gonna, oh, it made it 33.8. Okay, 1 more measurement. Okay, guys, you ready for it? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we're done. So the last measurement is 33.6 degrees Celsius. Again, it's fairly warm. I can touch it with my hand or pull it out and show you that the sample is still in the pot. There it is. Now, before I go, we can talk a little bit about the string has a tiny bit of contribution, and the other sample, the iron sample, it had a brass hook on it. So brass is not the same thing as, you know what? That's a steel hook. It just happens to be shiny, so I guess it's the same. It doesn't matter. It's the same thing. Sometimes you have brass hooks. This actually is steel, so that doesn't make a difference for this one. But both of them have strings on them, and some of them actually have different hooks of different materials. Anyway, most of the error comes from heat transfer. So go ahead, plot it out, find your line of mixings, and calculate what your specimen-specific heats are.